Hello, friends. Since we are presently concerned with the topic of fundamentals of fluid flow, and today we will discuss the equation of motion of the fluid flow, and we will discuss the dynamics part of the fluid flow. That is, we have to consider the uh, force causing the motion of the fluid flow, and as you know in previous lectures that the dynamic behavior of the fluid is analyzed by the Newton's law of motion, and which relates the acceleration with the forces. So as you know already that the force in dynamics part, this force is related with the acceleration, and we have to analyze this dynamics part with the help of Newton's law of second law of motion. That means we have to show the relation between the force and acceleration. So the fluid is in this assumption we have to take into consideration here that the fluid is assumed to be incompressible and non-viscous. So let us call what is the according to Newton's second law of motion, that you can see here that force is equal to mass into acceleration. So that I have written here Fx. That means you are we are analyzing the force of for the fluid flow along one dimension, that is along the x-axis, and m is the mass of the fluid and total mass of the fluid, and ax represents acceleration along the x direction. And now what are the different for the this uh, in the fluid flow the following forces are present, that you know that there are different forces that which are responsible for the fluid flow, and the force that just like you see have seen that there is the various types of energies are responsible for the fluid flow. So same is the case that there are different forces which are responsible for the motion of the fluid in dynamics part of the this fluid mechanics. And suppose Fg represents the gravitational force, and Fp represents the pressure force, and this Fv represents the force due to viscosity, and Ft represents the force due to turbulence. Fc is the force due to compressibility. So these are the different various forces responsible for the flow of this fluid. And suppose this from equation first that I already told you, I have shown you that this F is equal to m into xa. So if we elaborate this equation further, that's Fx is equal to m into ax, we can write here Fx is equal to Fgx, Fpx, Ftx, Fvx, and Fcx. That means this total force along the x direction, or you can say one dimensional motion in dynamics part. This force is equal to gravitational force, pressure force, turbulence force, plus viscosity force, and plus force due to this compressibility. If the force due to compressibility Fc is taken as zero, that is, it is if it is negligible, then put the value of Fc in this equation second as zero. We can write it as Fx is equal to Fgx plus Fpx and Fvx plus Ftx. So this compressibility force is has been shown zero here. So then if we show if we say that if there is a zero compressibility force, if the liquid is not compressible, then Fc term is neglected here. So then the equation is called a Reynolds equation of motion. Okay. So remember this point, that when we put Fc is equal to 0, this will be equal to this equation will be equal to equation Reynolds equation of motion. And second case, if the turbulence force, that is Ft, is negligible for the flow, then we have to put this value of Ft is equal to 0. Then the equation will be reduced as Fx is equal to Fgx plus Fpx and plus Fvx plus Fcx. So here there is no turbulence force, then this equation is called a Navier-Stokes equation. Okay, this is called a Navier-Stokes equation, and this will be discussed in further lectures. What is the this in full detail, what is the Navier-Stokes equation? But for time being, you have to remember that when we represent when we this turbulence force is neglected, then the this equation of motion is called Navier-Stokes equation. If the flow is assumed to be idle, ठीक है, if this is to be idle, if this flow of the fluid is assumed to be idle, then in that case, you have to, this viscous force is will be there will be no this friction, and this for idle flow you have to show that viscous force is equal to 0. Then when we put this viscous force is equal to 0 in this equation, then it will be equal to fx is equal to fgx plus fpx plus fcx and ftx. So this is called Euler's equation of motion. So remember, when we put, when there is an ideal flow and viscous force is equal to 0, then the equation of the motion is equal to this, then the force, this equation of the forces represented as the Euler's equation of motion. So this was all about the what are the forces responsible for the motion of the this fluid flow, and in dynamics parts of the fluid flow. And in next lecture we will study the what is Euler's equation of motion. Okay, thank you.